Okay, guys, this is going to be the last topic that we're going to discuss, and that is known as the box plot and the 5-number summary. So far we discussed percentiles. And remember, percentiles divide a group, a population, a sample up into 100 pieces, 100 equally sized slices. Now we're going to learn about quartiles. And quartiles are related to quarters, which means it divides the set into quarters. And how many quarters are in 100? Well, there are 4 quarters in 100%. 25%, 50%, 75%, and then that 100%. So quartile, which divides a data set into quarters. Now, there are 3 quartiles that we're going to focus on. Quartile 1, quartile 2, and quartile 3. Quartile 1 represents the 25th percentile of your data set. And we sometimes call quartile 1 as the lower quartile. Quartile 2 represents the 50th percentile, or the median for the data set. Remember, the middle number of a data set is called the median. And the third quartile, which we can sometimes call Q3, represents the 75th percentile, and we can call that sometimes the upper quartile. And if looking at the 100th percentile, which is quartile 4, that is the maximum. Using these quartiles with the minimum value and the maximum value, we create what is called the 5-number summary. The 5-number summary is a set of numbers that represents the minimum value, the quartiles, and the maximum value. So minimum, quartile 1, the median, which is quartile 2, quartile 3, and the maximum, which sometimes can be called the 4th quartile. We can also find what is called the interquartile range, abbreviated IQR, and that is the distance between the first and third quartiles for a data set. To find the interquartile range, it is quartile 3 minus quartile 1. Based on the 5-number summary, we can actually picture the data set. We can picture the distribution of our data to see if our data is skewed or does it have a symmetrical distribution. And we call that a box plot, or sometimes referred to as a box and whiskers plot. A box plot is a graphical representation of the 5-number summary that illustrates the shape of the distribution. Once again, the shape of a distribution is important because it lets us know if our data makes any sense. Now, there are other factors going into understanding the consistency of our data, which you'll learn more about in Stats 250. But for this right here, we're going to find the 5-number summary, and then we're going to construct our box plot. And here are the directions below on how to do that. Now, to find quartile 1, quartile 2, and quartile 3, step 1 says you must arrange your data in order from lowest to highest. The next thing you want to do is you want to find the median of the data values. And we know how to find the median of the data values from the measures of averages. After the data is listed in order from smallest to largest, cross off the ends until you reach the middle value. If there are 2 middle values, then we find the midpoint of those values by adding those 2 middle values up and then dividing by 2. Step 3, you want to find the median of the data values that falls below Q2. And the median of the data values that are below the 2nd quartile will be the 1st quartile. And step 4, you want to find the median of the data values that are above the second quartile. And the median of those data values will be quartile 3. And it's easy for us to identify the smallest value and the largest value because that will be at the ends of our data set. So let's find the 5-number summary, interquartile range, and construct the box plot for the data set. So let's put our numbers in order from smallest to largest. Now, the smallest data value that I can identify is 55. And what I'm going to do is here, I'm going to put that as my minimum. My minimum data value is 55. So I have one number down for the 5-number summary. And then we continue putting our numbers in order from smallest to largest. So that's 55. Then after that, I see 59. I see another 59 too. Then, before I do that, I see a 58. So let's put in that 58, 59, 59. Okay. For my 60s, I see 66 and 66. So 2 66s. And while we're speaking about our 50s, I see another 58. So I'm going to place that right over here. So sometimes it's hard getting the numbers in order, especially if the data set is large. That's why you keep checking to make sure you get everything. Okay. After that, I see 71. See it there? Another 71 at the end right here. 72. 74 and 75. 77. 78. 80. 81. And 83. Okay. All my numbers are in order. The minimum value is 55. My max is 83. So now let's find our median, which we can call quartile 2. So we cross off the ends until we reach the middle value. So it'll be 55 or 83. Continue that process. The median is going to be 71. I want to put that in red. The middle value of my data set is 71. Now, what you're going to do is to find quartile 1, lower quartile. So we're going to call that Q1. Take all the numbers that are below the median and find the median of those values. So basically, we're taking all of these values right here that is below the middle value and finding the median of those. So let's reset briefly. Now let's find the median of those data values. If you notice, we have two middle values, 59 and 59. Because they are the same value, we know that quartile 1 will be 59. However, if there are two middle values, you must add them together and then divide by 2. 59 plus 59 is 118. 118 divided by 2, that is 59. That's why we know that Q1 is 59. And now we're going to find the upper quartile, which is Q3. And we're going to focus on the data values that are above the median. So let's reset our data set. And I'm going to do this one in purple. So it won't be these values. Once again, two middle values, 77 and 78. So we add those numbers up. And you can also do this in your head to determine what the middle value is going to be. Then divide by 2. 77 plus 78 is 155. 155 divided by 2 is 77.5. And that is the 5-number summary. Okay. Now, after we have the 5-number summary, we're going to find the interquartile range. And the interquartile range, once again, says it is the distance between the first quartile and the third quartile. So that's going to be Q3 minus Q1. Let's write it down here. Okay. Upper quartile is 77.5 minus the lower quartile, which is quartile 1, that is 59. 77.5 minus 59, that is 18.5. That is the interquartile range. Last but not least, we're going to create our box plot based on the 5-number summary. So let's go down. And let's remember some things that we have. Now remember, the minimum value is 55, right? And the maximum value is 83. Let's go to our number line right here. Let's place a dot here at 55 for the minimum value. Place 1 here for the maximum value at 83. 81, 82, 83. Try to keep it consistent. We'll put it right here. Now we're going to place a dot for quartile 1, quartile 2, and quartile 3. Quartile 1, 59. Quartile 2, 71. Quartile 3, 77.5. Now, I know it's not perfect, so we're going to try to fix that up. Now, Q1, label them. Q2, which is the median. Q3, which is quartile 3. You're going to draw a box around the dot for Q1 and Q3, like this. The width and the height of the box doesn't make a difference. Just draw a box to the best of your abilities. Now, you know, drawing is not my strong suit, so it can be a struggle sometimes. After you do that, you're going to draw a line. You're going to draw a vertical line through the second quartile. After you do that, you're going to connect the minimum and first quartile together. You're going to connect the third quartile and the maximum together. Last but not least, you're going to draw lines, vertical lines through the minimum value and through the maximum value. I missed that one completely. And this here is your box plot. All right, guys, that is it. That is it for our 5 number summary for our box plots for the interquartile range.